We're going to look at calculating work here, which, as I've said at the top, is actually energy. And so, work is measured in joules. And we have a very simple formula which we need to know, which is work equals force times distance. And so, if we have a block which is 10 kilograms and somebody pushes it 5 meters, the work done is the force times the distance. Now this is interesting because what we've actually been given here is the mass. And so how do we turn mass into a force? Well, the force of a mass is its weight, and you may recall that force equals the mass times gravity, which we need to know, which is usually 10. So this is 10 times 10, which equals 100 newtons. So, looking at this, we now have found the force, which is 100 newtons, and we can multiply it by the distance, and so the work done, which is the energy, equals 100 newtons times 5 meters, which equals 500 joules. So it has taken 500 joules of energy to push this block 5 meters. And it really is that simple. Once again, if we were to think about them asking us a slightly devious question, if they told us that the work done was 1000 joules and that the distance was 10 meters, they could ask us for the mass of the object. Now, our formula, once again, looking at this, is work equals force times distance. We have the work, which is 1000, equals our mystery force times 10, which is the distance. So when that comes across, we get 1000 divided by 10 equals our force, which equals 100. So our force is 100 newtons. Now 100 newtons in kilograms, we divide by 10, because gravity is 10, so divided by 10, which equals 10 kilograms. And so that way we've just rearranged the equation of work equals force times distance to find out the force and therefore find out the mass. It all stems though from knowing that work equals force times distance, and then once you know that, they'll give you 2 of the formulae and you've just got to fill in the third. It really is that simple again.